Okay, one cool new feature of Java 8 that I wanted to show you guys is Lambda Expressions. Lambda Expressions, some of you may be familiar with them. They're available in certain other programming languages other than Java. They've been available in those for a while, and also you may have read about them or talked about them in your computer science courses. And what the benefit that Lambda Expressions provide you is a much more succinct and compact way of coding little pieces of functionality in certain cases in Java. Cases where in the past you would normally use an anonymous inner class, if you would provide an anonymous inner class. And that was kind of a bulky syntax, quite a bit of code to write. The other benefit that Lambda Expressions provide is they allow you to store, to basically do what you can do in JavaScript. In JavaScript, you can define a function, store it in a variable, and then as an object. And that function is treated like an object and can be passed around. So you can pass one function into another JavaScript function. And if you've done any JavaScript programming, you guys may be familiar with that. And that can come in handy. It allows you to do certain techniques by passing functions around to other functions. That comes in handy and it can be useful. It also allows your code to be a little more succinct and not quite so bulky. Well, beginning with Java 8, Lambda Expressions became available, and Lambda Expressions also allow you to define a function, or basically a method, an interface method implementation, and to store that in a variable. And then you can actually pass that around your program. You can pass that as a reference. You can pass that as an argument to another method, to another function, even in another class. And I'm going to show you guys some examples of that. But you recall I mentioned that Lambda Expressions, what they are is a much more succinct and condensed way of coding what you would otherwise have coded in the past using anonymous inner classes. And let me show you some examples of that. You may have recalled doing that in the past with earlier versions of Java for things like event listeners, attaching event listeners to components, for example, like UI components, such as buttons or JPanels in Swing or in AWT, things that generate events. You would attach an event listener or an action listener to those components. Or in other frameworks, you may have other classes that generate events, and you would attach a listener of some sort to it. And often the way you would do that is you would attach it as an anonymous inner class, because you had to provide an implementation of an interface method. So these listeners, these event and action listeners, were usually interfaces, and you had to supply an implementation of that interface. Well, you could do that by writing a standalone implementation class called an adapter, like an event adapter. You could do that by extending one of the existing event adapter classes, or you could keep your code kind of, reduce the size of your code base by just writing it inline as a implementing the interface method inline as an anonymous inner class, and that's what the anonymous inner class was used for. But that can be kind of bulky. Let's take a look. If you look at my Eclipse here, I wanted to kind of show you guys what you would traditionally do before the appearance of Lambda Expressions in Java 8. So this is how you would conventionally do it. If we take a look here, I've got a code example in this main class of an AWT button, a Java AWT button, which you would normally use if you were creating some sort of desktop UI or console application UI. You would create buttons and panels and so forth, and to those components you could attach listeners, event listeners, action listeners. Action listeners are a specialized type of event listener. So here we have a button that's being constructed here, being instantiated, and then we call the button's add action listener method. That's a method that's available on these components, and that allows you to attach your action listener so that you can listen for action events. And an action event is fired from one of these things, such as a button, whenever the user clicks the button. You want to be able to detect that in your program, for example, and so you'll add an action listener using the button's add action listener method right here. So the way you would have traditionally added your action listener conventionally, most typically, was you would supply it as an anonymous inner class. And the reason for that was the action listener, or action listener, is a Java interface. And that interface, if we hover over it, java.awt.event.actionListener, this interface is designed for receiving action events. And that interface had one interface method, which was called actionPerformed. It is called actionPerformed. And so you see, this is an anonymous inner class. This is the kind of the traditional approach to inlining the code for your action listener. It's an anonymous inner class. You construct an instance of that, an object of that implementation, and then you have a code block here to implement the interface. And because the action listener interface, if you look it up, it has one method, action performed, right here. So we need to override that and implement it, provide an implementation, which I've done here. The action performed method takes one argument. So that method gets called with one argument, which is an object of type action event. So it gets supplied an action event, and I've given that action event argument a name. I've called it action. And when that method gets called, we want to execute some code. Now, to keep this example simple, I'm just system out print lining a message. So it just outputs this message. The test button was clicked. And that's how you would have done it using an anonymous inner class. And you see that the compiler accepts this and builds it and accepts it as valid syntax. And you know that from your past work in Java. And then here, well, let me do this. So that's the anonymous inner class approach. Now you'll see, because my compiler and Eclipse is set up using Java8, here I want to show you that you can do exactly the same thing, but you can do it in one line. So here I'm using an anonymous inner class to define my action listener, and you see that that occupies about 4 or 5 lines here. Down below, I'm using a Lambda expression instead. And by using the Lambda expression, you see that to execute, just to system out print line a message when one of these action events is received, we can code that in just one line using a Lambda expression. But you do have to use a quite different syntax, which may look a little unfamiliar to you, and I'll go over this syntax. So let me do this. Let me delete the anonymous inner class approach so it doesn't confuse anybody. Now, if we use just the Lambda expression, we scroll down here, you see that I'm still calling the button's addActionListener method as before. But instead of supplying and defining an anonymous inner class here, instead I'm using a Lambda expression. Now, what is a Lambda expression? A Lambda expression is designed, it's a new way of allowing you as a developer to implement an interface. If that interface has one method, a single method, you go ahead, you can use a Lambda expression to implement it. Otherwise, you might want to use an anonymous inner class instead. Because after all, if you have more than one method to implement, even using a Lambda expression, even if you could, you would not gain much in terms of brevity. But if you only have one interface method to be implemented, then you don't have to bother with all the boilerplate of an anonymous inner class and the curly braces and the nested brackets and the method declaration and all that and the types. Instead, you can use this Lambda expression syntax and do it in one line. Or, if you want to execute more lines of code, it may be longer than this, but it definitely will be more succinct than using an anonymous inner class. So let's look at that syntax that you have to use in this line. So I'm going to select the Lambda expression only. So there you see, that is the Lambda expression right there. Everything else is more traditional Java code, but we're supplying as an argument to this addActionListener method, we're supplying a Lambda instead of an anonymous inner class. So we've done that replacement there. And here is the syntax for a Lambda expression. You see this odd-looking operator, which is new to Java 8. That's the Lambda expression operator. You need that for a Lambda expression. To the left of that, separated by a space, you're going to list any arguments to the interface method that's being implemented. Remember, a Lambda is a way of implementing one interface method. So if you have an interface with one method, you can define the implementation of that interface using a lambda. So we need to list any arguments to the interface method to the left of this lambda operator. And that's what I've done here. However, with lambdas, you don't need to bother with types. You don't need to declare the actual Java types of arguments or of return values. You don't need to declare them. So you also see that there's no public void and so forth. There's also, you see there's no return type declared. So we don't have void written here. We don't have public access modifier or void or return string or anything like that. You don't need to bother with declaring the types, neither the return type nor the types of the arguments. You only need to provide an argument name, a variable name for the argument. And in this case, as we saw above, there's only one argument to the action performed method. So what I've done here is I've provided a name for that argument, the action event argument. I've given it the name action. And in fact, if I hover over it, you can see that the compiler knows the type. Even though I haven't declared the type, the compiler does know the type inherently. And the reason it knows the type is that this action argument is of type action event. The reason it knows that is that the compiler, when it sees this lambda operator, when it knows it's a lambda expression, it goes and it looks at the corresponding interface. It looks at the action listener interface, and it discerns what the type should be from looking at that interface, as long as the interface is on your class path or your build path. So I've got the argument list here, and in this case there's only one argument. And then the lambda expression, and then on the right of the lambda expression, you supply whatever code should execute. So this is the body. This right here is the code body of your interface method, your implementation. And this is the code that should execute when that interface method gets called. So when an action event is fired by the button, such as when the user clicks the button and an action event is fired, internally, the action listener, your implementation class of the action listener interface, its own action performed method gets called, and that method is called with a single argument of type action event, this action variable here. Well, when it gets called, this is you're specifying this line of code to execute in that case. And you see that in this case, we only want one line of code to execute, a system.out.println statement. And when you only want one line of code to execute, you don't need to enclose it in any curly braces. You don't need the code block braces that you would for a function or for an anonymous inner class. So that allows this code to be very succinct and very, very condensed. You don't have the parentheses, you don't have the types, and you don't have the curly braces or the code block around the code that you want to execute. And also, because this line of code is part of a lambda, and the lambda is itself an argument to a function, you don't need to bother with the semicolon at the end of the line either. Now, what if we did not just want to execute one line of code? What if whenever an action performed method was called, we wanted more than one lines of code to execute? So how would we code that? I'll show you that. In that case, you do enclose your code body in braces, curly braces. So let's do that. So you see, and also you need to start using semicolons at the ends of lines at that point. So you see now this looks a little bit more like a conventional function or method. Our lines of code, our code body, is enclosed in curly braces, and the lines are delimited by semicolons. So you see that. And this looks almost as though we've taken a method body and transposed it inside here. And so right now we have one line of code, and you see that the curly braces are optional. Even if you have just one line of code, you can opt to use curly braces and enclose them in curly braces if you want and make it a code block. However, you don't have to, and it's more condensed not to. But using curly braces, then we can actually do more than one lines of code in our Lambda. So if we wanted to output several messages, we can do that. because it's enclosed in curly braces, the optional braces. So you see that the compiler does not complain about this. There's no red flags because these three lines are enclosed in curly braces, beginning here and ending here. And that lambda expression fully satisfies the compiler as to what should happen when an action event is fired. That supplies an action listener to the button. So let's go back to a single line of code, the way it was. And you see I'm leaving the curly braces there, so I'm going to encircle our single line of code in curly braces and save that. And you see that is still valid syntax. The compiler has compiled this in Eclipse, and it's not red flagging it because that is also valid syntax for a lambda expression. The curly braces are optional, and if you have only one line of code, you can get rid of the curly braces if you want to. So let's do that now. So because we only have a single line of code, we can get rid of the curly braces and therefore the semicolon as well. But this is interpreted by the compiler just as though we have implemented the action performed method and that we just have a single line of code as the method body. So this would function just the same. Now what if, in the case of the action listener interface, the single method takes a single argument. So action performed takes a single argument of type action event. What if the interface method took more than one arguments? How would you code that in a Lambda? I'll show you that. In that case, you need to enclose the arguments in parentheses. So when you do that, when you use the parentheses, now it is clearer that this is an arguments list, a function argument list. It's starting to look like what you would see in a Java method, a traditional Java method, because we have a list of arguments. So for example, we could have more than one arguments. But you don't supply the types of those arguments in the arguments list. You just supply names, a name for each argument, because the compiler needs to know how many arguments you're providing or how many there are. So you're providing those. You don't supply the types. You do not list the types of those arguments. The compiler infers the types from the interface itself, from the interface that you're implementing. And also you see in this case that the compiler is flagging this with a red flag because it knows that the action listener interface does not, the action performed method within it does not take 3 arguments. It knows it takes only 1 argument. However, just to show you, this is how you would do that. And that applies whether there's 3 arguments, 4, 5. It's the same for any number of arguments greater than 1. If there's only a single argument, we can get rid of these other arguments. And if you like, you can leave the parentheses. So in your Lambda expression, the parentheses are optional. You can decide to always use them if you like when you specify the arguments to your Lambda. So even if there's only 1 argument, you can surround it in parentheses if you like. However, by convention, most people do not. Most code that I've seen for Lambda expressions, when they have a single argument in the argument list, they tend to get rid of the parentheses. And you see that is also valid syntax. Now what if the interface method that you're implementing in your Lambda takes no arguments? How would you show that to the compiler? In that case, what you need is a set of empty parentheses. That tells the compiler that the interface method you're calling takes no arguments. And to do that, you just have a simple open and then a close parentheses to show that. This is how you would code it. But of course, in our case, there is one argument in the case of action performed. So let's restore that. So you see now it all compiles. So I've shown you how to write a Lambda expression regardless of the number of arguments to the interface method that you're implementing, and also how to write it regardless of how many lines of code you want to execute in that Lambda expression. You can have any number of lines of code in your Lambda expression to be executed. It's just if you have more than one, you have to use curly braces. You have to enclose them with curly braces. If you have only one, you do not. So let's get rid of, so this particular example that I showed you is great as a simple example of why lambdas are a benefit, because it shows you how much it can condense the code. However, it's not, I want to kind of go on, it's not a good example for running. I want to show you a richer example of using lambdas. So let me delete that. And let me go on to a more complex example of a lambda expression. So as I said, when you have an interface with a single interface method, even those interfaces that are part of the standard Java library, you can supply an implementation of that interface. In lieu of an anonymous inner class, you can supply it as a lambda expression. And so that's what I've done here. Let's look at how we can use a lambda to implement the comparator interface. So the comparator interface is a generic interface, and it takes an erasure, a generic type, to specify what types of objects, or what class types you're comparing. And the comparator interface allows you to define custom behavior for how to compare two objects of that type. And you see that in this case, I'm defining a comparator of type vehicle. So that is the type vehicle. And vehicle is a custom class that I have written. I've just created it for this tutorial. And it's up here. It's actually an inner class of our main class. So this class is called vehicle, and it's just an inner class, a static inner class that I've created. You see it's pretty simple. I expanded it here so you can see it. It has a single field, a string field named vin. It has a single constructor which takes a string as a vin, and sets it on the field. And then you see that it has a getter and a setter to get and set the vin. And then you see that it has a simple toString method which will output the vin. It outputs the word vehicle, colon, and then the vin. So that's our vehicle class. But down here is the real code that you're interested in. This is the code that uses a lambda expression to implement the comparator interface for vehicles, so that we can define our own custom comparator for vehicles, which allows us to compare two vehicles and order them, to compare them to determine and return which one is greater and which one is lesser. Of course, greater and lesser are relative terms, and they have different meanings for different objects. A greater string is one which is alphabetically sooner, or alphabetically earlier in the alphabet. And if you use a string comparator, it will order those strings alphabetically by default. An integer comparator would order them numerically, ascending, and so forth, and so on. But when it comes to custom objects that we ourselves define, we're going to need to define how the comparator should compare them, because there's no automatic assumption of which vehicle is greater and what the logic is for that. And so that's what I've done here. In the past, you would have implemented the comparator interface by writing your own separate standalone class that implemented comparator, or by supplying an implementation as an anonymous inner class. But I've replaced that here with a lambda. You see also that by replacing it with a lambda, I can assign it to a variable. So in blue, selected is our lambda, and then over on the left side of the equals, the left side of the assignment, I've assigned it to a variable called vehicle comparator, which is of type comparator vehicle. So here is the lambda, and you see that the interface method we're implementing an interface, which is the comparator interface, and that has one method, compare. And compare takes two arguments. The types of the arguments are generics, the generic erasure, which would be vehicle in this case. So it takes two vehicles, the compare method. So our arguments list has two arguments. And you see that when I hover over them, v1 and v2, the compiler already knows that these two arguments are of the type vehicle. And it knows that because it has looked at the comparator interface on the class path and determined that the compare method that we are implementing takes two objects of the erasure type. So now that's our arguments list, and then we have the lambda operator to tell the compiler this is a lambda, and then we have our code body. So from this opening brace to this closing brace, is the code that should execute inside the compare method. And what this code does is compares v1 against v2. Now I decided for a very simple simple implementation of this compare method to keep things simple for the tutorial. What I do first in the first line is check if either vehicle is null, and if either one is, then it just throws an illegal argument exception. It's not going to compare vehicles if either one of them is null. However, if neither one is null, then what it does is it takes for v1, it gets v1's vin, and for v2, it gets v2's vin, and then it just compares v1's vin against v2's vin by calling the string version of compare to, so string.compare to. And so what that does is it compares the two vins as strings, and that means that it's going to order them, alphabetically. So it's going to order the vins alphabetically, and therefore our comparator, the vehicle comparator, is also going to order the vehicles alphabetically by VIN. So this comparator, as defined using the lambda, orders the vehicles alphabetically by VIN. So that's how you would do that with a lambda expression. If we scroll down, you see that I do a test of that. I create a list of vehicles, use array as list, and instantiate two new vehicles. And the order in which I instantiate them becomes the order that they're added to the list. And you see that I add them deliberately in an order in which the VINs are not stacked alphabetically. They're in reverse alphabetical order. So the vehicles are in reverse of their natural ordering, you would say, in this list that I've created. And then what I do is in this test is I output the order of the vehicles first before sorting. And then we call the list.sort method, which is available. It's a method that's available to the list interface. And the sort method allows you to sort a list if you supply it with a comparator. And so that's what we've done. This vehicle comparator object, which is defined as a lambda, we supply that to the list.sort method here. So we sort our list using our custom comparator, and then afterwards output the results of that, just output the ordering. So let me run that. I'm going to expand the console so you can see the output, and I'll run that. It's running. Okay, and you see the output. So before sorting, the vehicles were in this order, and you see that they're against their natural ordering, whereby the VINs are not alphabetically ordered. The VIN beginning with X comes before the VIN beginning with A. However, after sorting, the vehicles are in this order, and you see that the vehicle whose VIN begins with A is sorted ahead of the vehicle whose VIN begins with X. So that's a simple test of the comparator. It shows that it works. And I've shown you now how to implement the comparator interface as a lambda expression. You would do the same thing for virtually any interface that you want to implement inline using a lambda expression. The caveat is you would normally do that with interfaces that have a single interface method. There are some more complex nuances to that, which we'll get into in a later video.